Hi everyone, I'm Nancy.
I'm Kian.
I'm Ethan.
We're Team RGB. We feel privileged to be part of the Hack 2022 competition. In the Hack 2022 competition, there are 4 stages of challenges. The first stage is to put together a mini robot with the parts giving, and it should be able to move forward, backward, and turn and rotate its arms. The second stage is to design an arm for the robot, and it should be able to pick up the specific items and put it into the backpack. The third stage is to program multiple faces by using LCD screen for the robot. And the fourth stage is to program a dance for a robot. Here are the parts we got for the hack competition.
So in addition to the Hack 2022 challenges, we also had challenges in programming. So the first one would be to read character inputs from our keyboard on our computers and transmit them to the microcontrollers. Then using these keyboard inputs, we had to relay commands to the different systems of the robot. And so this is kind of our approach. So we figured we use Java to take the keyboard inputs and then via Bluetooth, send these keyboard inputs to the ESP32, and then finally use UART communication to send it to the Arduino. And so this is kind of a look at our Java code. So you can see here that when we press any key on a keyboard, well, not any key, but specific keys on a keyboard, we assign a variable a certain number. So you can see state equals 1, state equals 2, and so on. And then in a loop, using using the assigned state number, we print a specific character to the Bluetooth port, and this is transmitted to the ESP32 for it to use in its code. Here we can actually see the character inputs being used by the ESP32. So you can see if the characters F, we're going to print a 1, the character 1 to the serial monitor, or if it's an S, we're going to print the character 2 to the serial monitor. And on the bottom, we can see that we added kind of like a second check for us. So if you press W, the robot should be moving forward, or if you press F, the robot should be moving backward, and so on and so forth. And here is kind of just like a slide on UART communication. So unfortunately, the Bluetooth, the Arduino does not have Bluetooth capabilities. So we had to find a different way to communicate via ESP32 and Arduino. And to do this, we use UART communication. So we'd connect the RX and TX pins between both microcontrollers. And doing that allows serial communication between the two. So we can print certain characters back and forth from the ESP32 and Arduino. And here's an actual look at the Arduino code implementing this. So recall on the ESP32, we printed certain characters that had numbers in them. So if we printed a 1, the Arduino would take this and store it in a variable called command that we see at the top of the loop. And then it'd go through each if-else statement and check against it. So in this case, if it was 1, it turns specific motors on to cause motion, or it use the servo motors and rotate them, or do whatever it needed to do. And here's a look at the other code. You can pause and read through this if you'd like, but it's basically the same exact implementation, and each if-else statement has different consequences. And so finally, this is our LCD code. So rather than having a bunch of statements on the page and making it look kind of confusing, we decided to make a function to call on. So it would just print different faces. So you can see here, if we do print face 1, it'd print the first face, or it'd print the 0th face, and so on and so forth.
Throughout the 3 days hack competition, we tried about 10 versions of ARM design. Generally, they fall into 3 kinds of designs. The first one is a shovel, the second one is a round hook, and the third one is a triangle pointer with a small hump on the arm. On the day we first met with our team members, we came up with the idea with a pair of straight arms holding a shovel at the end. This design was overturned because of 2 reasons. The first one is that the power is not strong enough. The second one is that there's no water against the shovel in the field, so it may push the boxes instead of picking up the boxes and putting it into the backpack. So we changed our plan after the first test. The second version is a round hook. However, this one didn't work well. The box is falling down to the arm. The third one is a straight triangle hook. We added a small hump to avoid the boxes falling down to the arm. Finally, we settled on hybrid arms. One hand is a shovel and another hand is a straight hook.
All right, so I'm going to talk about our robot's functionality. Good news first. The shovel arm that we did design does successfully deposit the payload. Unfortunately, a loose RX jumper wire prevented us from demonstrating this on the last day of hack. We do have a short video from the day after hack for no points, of course, just to demonstrate this. Nancy, could you play that, please? So when an object is placed in the shovel, it does deposit into the backpack. Okay, also, we had troubles with the wheels not spinning, the hex nuts securing the motors for the wheels rubbed against the wheels, which was a significant challenge for us. Also, we were unable to get a secure Bluetooth connection for more than a few commands before it crashed, with possibly due to so many ESP32s being in the same vicinity. Another thing was the LCD screen is very dim and will actually completely cut out when the arm servos are engaged. Next slide, please. All right, so our accomplishments and final product. So yes, the shovel design does seem to work to a degree. The team members are leaving hack with a much better understanding of Arduino, feathers, and microcontrollers, circuit building and breadboarding, CAD, and serial communications using UART. Also, the in-person participants feel much more comfortable working and tinkering in the makerspace. Our robot is still not fully functional, but the team is committed to diagnosing bugs over the next week or so and bring it to full functionality. Challenges faced were the previously mentioned screws causing friction with the wheels and preventing them from moving, untidy wiring leading to loose jumper wires that were difficult to diagnose, and also a lack of foresight and time to print multiple iterations of arms, shovels, and so forth. And then also just the mysterious lack of current to power the LED arms and wheels. What we do differently is we would try to print multiple designs at the same time. So we would save time in 3D printing and just have more options. Also, a taller shovel would have a farther reach to help get the TIE fighter, which the shovel would not have worked with. And then also thinner walls would have helped with the current draw problems. Also, in trying to resolve the problem of the wheels getting caught, we irreversibly superglued our wheels on, which cost us valuable time when we had to take them off later. The hook arm was a little bit too straight and would benefit from just maybe a slight quarter circle curve. And then also cleaning wiring management, of course, would have made it easier to diagnose loose jumper wires that prevented us from demonstrating our robot. Team RGB would like to thank Wes, the sponsors of Hack 22, and the mentors for letting us participate this summer. It has been a privilege and an honor. Thank you.
Thank you.
Thank you.